Okay. So we're going to go over logarithmic functions. And a logarithmic function is almost like a type of inverse. Have you guys talked about inverse functions? Okay, of an exponential function. So we have an exponential function. A logarithmic function is almost the inverse of it. The way they relate to each other, okay? So if we have some power, and it's to the base of a, okay? Its exponent, keep these colors a little nicer than that. And the equivalent, what if it's equal to? The equivalent form with a log, okay, is the exponent becomes the answer in the log form, okay? Our answer before becomes the number in the log, and the base of the log, I guess I gotta find red again. The base of the log is known as the base of the exponent. So base of an exponent always ends up becoming the base of the log when we go to work between the two. Okay? So in the very first question, they've written it as an exponential function. What we're going to just practice is writing this as a logarithmic function. Okay, so we're going to use the same highlights as we did here. So we know the power is going to end up being the answer in the end. Okay, so when we go to convert this to a log, we already know that our power will become the answer. So we know we're going to have our answer is 3 is equal to, okay, 3 is equal to our base in this case is going to be the base of this exponent, which is the number 4 here. So we're going to have a log base 4. So highlight it. So we set base 4. There it is. And finally, our value of our log is actually the answer of the exponent, so 64. So it's going to be the power of the value of 64 in this case. Okay, so looks a bit confusing when we go through it, but really what we're just focusing on is how to rewrite something here. Okay, so one way to always remember is your base is still always going to be your base. This is the base of a log. Okay, your exponent becomes your new answer, and your answer becomes a new part of the question. So kind of like they flipped inverted from each other. So what we're going to do is we're going to use this log, or we're going to use, we're going to actually use a log and put it back into an exponential function to help us solve this. Now in your calculator, you may be, depending on what calculator you have, be able to put things into log base 2. But what we're going to do is we're going to focus on actually using these back and forth from exponents to logs to help us solve things. So this log, we're going to do vice versa when it tells us to evaluate in the second example here. We're going to put it into an exponential function. So let's try to talk about this. If this is the base, that means it's going to be what part of the exponent?
The base of the exponent.
The base of the exponent, right. So we know we're going to have base 2. Our power is going to be what?
The answer.
The answer. Do we have an answer here?
No.
No. Our answers are unknown, so we're going to call it x. And the value in the log is going to be, is going to be our new answer. So this becomes a much simpler question to look at. In the log form, confusing on what our answer is going to be. But when we're looking for the exponent, we know that we can put 2 to a certain number to get 16. Do you happen to know what number that is? Yeah, exactly. So we know that x, in this case, is going to be the equivalent of 4. Okay, so let's take a look at that.